All right, we're going to talk about segments. Whenever I say segments, there's no other context of segments other than line segments. So segments is a fancy word for part. So a line segment is a line part. Okay? So a line segment, here's a definition, is a part or a segment of a line consisting of two endpoints. So we don't say a beginning point and an end point in geometry, we just say endpoint. Okay, and all, not just the endpoints, and all the points between them. Okay, so we would call this line segment or segment AB, or we would use our fancy symbol above AB. We could also say BA if we wanted to. The order doesn't matter. The order only matters when we get to rays, or what we call half lines. Okay? Because there has to be like a beginning point, but we still call that an end point, ironically, in a ray. So these are two endpoints. There's no beginning and no end, there's just two endpoints. Okay? So when I talk about this line segment, I'm not just talking about A and B. I'm talking about A and B and everything in between them. Okay? All right, now, you guys should know this word too, geometric objects that have the same size and shape are called what? Starts with the C.
I'm thinking. Congruent.
Congruent. There you go.
Good job, Tristan.
Thanks.
You speak sloth? Great. Okay. So here's where semantics come in. If these chairs are exactly the same, I would not say these chairs are equal.
How do you spell congruent?
Congruent. Okay? I would say these chairs are congruent. If they have the same dimensions and the same size and shape, they're congruent. They're not equal. Equal is a grammatical thing, but equal only applies to numbers. So the Constitution is grammatically incorrect. All men are not created equal.
Only numbers are equal.
Yes, only numbers are equal.
It should say all numbers are created.
So do we have equal number of opportunities? Yeah, we can say that. But we can't say we have equal opportunities. That's incorrect. We have equal number of opportunities, okay? But if we have the same opportunities, that's not equal. That's the same, okay? So those are semantics that we'll get into later, but two geometric objects that have the same size and shape are congruent. Here's the symbol for congruent. Same size and shape, or same shape and size. So there is an equal sign in there, but then there's a little squiggly on top. That's what congruent means, and that's honestly how I'm going to spell the word congruent. When I'm listing a definition, I'm going to say two congruent triangles, two, that symbol, and then the symbol for triangles. Okay? So we're gonna use a lot of shorthand in this class. So congruent segments. Basically have the same length, because you cannot draw a different shape of a segment. They have the same length. So for example, if I drew another line segment there, and I put a little hash mark there, I would say CD is congruent to AB. Okay? If I just wanted to talk about the lengths of a segment, then I would just put the two endpoints. So I could say CD, or the distance between C and D equals the distance between A and B. But do you see why we can say equals there? Because distance is a number. So CD equals AB. But line segment CD does not equal line segment AB. But line segment CD is congruent to line segment AB. Semantics. Loads of fun. Okay, so these little tick marks, we call them tick marks, those little hash marks there, that means wherever you see another hash mark like that, that has the same dimension, same length, okay? Or same measure. All right, now this is where we get into some fun things. A lot of you know a lot of this, but reflexive, we're gonna talk about properties. Reflexive property of congruency. Reflexive property of congruence. These are the properties of congruence. You ready for this? AB is congruent to BA, or AB, or itself. AB is congruent to AB. Because this is the same line segment. So reflexive property says line segments are congruent to itself. Well, duh. All right? There's going to be a lot of well, duh in this class. Okay? Reflexive property, believe it or not, you're going to use this in an argument a lot. Reflexive property. Here's another property. Here's another property. The symmetric property.
Symmetric starts with C, doesn't it?
Symmetric prop congruence. Okay, here's what the symmetric property of congruence says. If AB is congruent to CD, then CD is congruent to what?
AB.
AB, that's right. Okay, that's the symmetric property. So far, so good? Are your brains hurting? Okay, this is a fun one. This is a little transit, a little trip on the train here. Transitive property of congruence. Get ready. If AB is congruent to CD and CD is congruent to EF, well, guess what?
Oh man, what if EF was congruent? AB.
Yeah, so AB is congruent to EF. So see how we went on a little logical journey there? Well, let's see. If AB is the same thing as CD and CD is the same thing as EF, that means that first thing has to be congruent to the last thing. AB is congruent to EF. Transitive property. So that's kind of the way I remember it. It goes on a little journey, the transit. Okay? We talked about segments. We talked about congruent segments and congruent statements. We talked about three, well, properties. You guys remember the three properties we talked about? Tristan.
Reflexive.
Reflexive.
The transitive.
Transitive.
And then the symmetric.
Symmetric. Okay.
What was the first one again?
So remember, the reflexive property says that a line segment is, or any figure is congruent to itself. Okay? Or depending if AB, line segment AB is congruent to line segment BA. It's the same line segment. So that's what reflexive means. When the line segment looks in a mirror, the reflection is itself. That's a good way to remember it. Okay, what's the symmetric property?
Property of congruence. If AB equals CD, and CD equals AB.
That's right. But remember, congruent to, so these are properties, so we can't say that line segment AB is equal to line segment CD.
Oh, that's why it's a weird little curve.
So yeah, so that means congruent. So it's just semantics. I know what you mean when you say equal to, but I could say the length, if the length of AB is equal to the length of CD, then the length of CD is equal to the length of AB. And that would be a symmetric property of equality instead of congruence, okay? But symmetric property, basically, it's symmetrical if you can reverse it and it looks the same type of thing. Well, it's, yeah, congruent statements are reversible. That's what symmetric means. Transitive property. Remember, if the first one is congruent, do you know this one?
Yes.
Yeah, tell me.
It's AB equals CD, CD equals EF, and then AB equals EF.
That's right. So if blah and blah and blah and blah, then blah and blah. Okay. So that's we've dealt with the transitive property and other things before back in pre-algebra, but you probably forgot, which is understandable.
I definitely forgot.
Okay, so now here's the deal. A postulate. You're going to hear this word a lot in this class. A postulate. What's wrong with that word?
Wait, it's two separate words?
Oh, I thought a postulate was a postulate, not a postulate.
A postulate. No, it's a postulate. Okay? Is a statement that is accepted as truth without proof. Okay? Is a statement accepted as truth without proof. Well, how can you even say that? How can you even say that? Well, let me give you an example of a postulate. So a segment addition. So if B is between A and C, then AB plus BC. That's a postulate.
So a postulate.
Well, there's no, like, we just take it as facts, but, like, who can prove it happened?
Yeah, you can't really prove it wrong or prove it right. It's just like, well, duh. Yeah, that's like 1 + 1 = 2. We'll prove it.
Says you.
What? So that's the other thing about math in general. 2 + 2 has always equaled 4 since the beginning of time. And even before that. It's outside of time. Math is outside of time.
That hurts my brain.
Because now the words 2 and the symbol 2 and the symbol 4 and the words 4 that we came up with. But the concept 2 + 2 has always equaled 4. Inside of time and outside of
I don't
time.
think that you came up with those.
I didn't. As we, when I say we, I mean,
You mean
we as
people before
humans.
you.
Yeah. Okay, so here's one postulate. Postulate 1. Now, when you use these, you can use these postulates in an argument. Well, according to postulate 1, I can say this. And we've agreed that postulates are things we can use without proof. So it's okay to say this, okay? Now, this is called the ruler postulate. You can say postulate 1 or you can say ruler postulate. Here's what the ruler postulate says. There's lots of fancy words that I'm going to give you in a really confusing way, but basically the postulate says we can use a ruler and it's acceptable in this class, okay? So here's what the ruler postulate says, and get ready to write and never look at this again. The points on a line can be paired in a 1-to-1 correspondence with the real numbers such that, there's two parts to this. Number one, any two given points
Oh my god.
can have coordinates 0 and 1.
That's a lot of writing.
Two, the distance between 2 points is the absolute value. You guys remember absolute value
Sure.
of the difference of their coordinates. So here's what this says in fancy talk. This is what this says.
Oh my gosh, that's such fancy talk.
What's the distance between 2 and 5?
I don't know. What's the
3,
difference?
yeah, it's 3 units. Okay, so you can either subtract 2 minus 5 and take the absolute value of it. What's the absolute value of 2 minus 5?
3.
3, because it's -3 and then absolute value makes it 3. But you don't say, how far is it to Las Vegas? Well, it's -1,000 miles. No, it's 1,000 miles. So that negative is just a direction, okay? You don't care about direction when you're calculating distance, all right? Or you could say absolute value of 5 minus 2, which is also 3. But 3 what? Well, just 3. Can we just agree that the distance is 3? Yeah, we don't have to prove that the distance is 3. I mean, we can count it out hopping from one point to another, but see how the ruler postulate says we can use this as a system of measurement to calculate distance between 2 points and to really say that we've declared that this is 1 unit between 0 and 1. But we could have declared that in between 2 and 5 is 1 unit. But we're declaring that this is 1 unit, so we can calculate distance using this in between each point. Isn't that too fancy and like driving that point into the ground? But there's a lot of that, remember, in geometry. We're driving that into the ground. Well, we're just going to agree that we can calculate distance this way, okay? And we don't have to prove that it's legal. It's just legal.
Is there another postulate?
So distance
Oh, okay.
is basically the measure of a segment connecting 2 points. Okay? So, and it's represented by 2 capital letters without a symbol on top.
Any 2 capital letters?
Yep, so if I say AB, that means the distance between A and B. So if I say OK, that's the difference between O and K. Okay? In geometry, if I say OK, that means the distance between O and K. So distance is always positive, so you can always calculate it this way. So D equals absolute value of point A minus point B, or B minus A, because if you do the absolute value, it doesn't matter what order the subtraction is in. Okay? So if you have absolute value, then the commutative property for subtraction kind of works, right? Because 3 minus 5, absolute value of 3 minus 5 is the same thing as absolute value of 5 minus 3. Okay? So this is just an easy way of saying it doesn't matter what order you calculate the subtraction in. All right? You don't have to worry about doing the bigger number first. Just subtract it. take away the sign, take away the negative if there is a negative. That's it. So far, so good? Okay. Again, this is stuff that you didn't have to know this information to answer problems like that. You could have calculated the distance all on your own, and you wouldn't even have mentioned the word absolute value in your brain at all. You can figure out distance between 2 points on a number line. All right, a little bit more in lesson 2. Here's postulate 2. And this is called the segment addition postulate. And most of the time, the meaning of the postulate is in the name. So you can probably guess what this is, but if I say if B is between A and C, then AB plus BC equals AC. So it's always easier when I draw it. So here's A and C. If B is somewhere between there, and the word between means on a line segment. So technically, Tristan is not between Hallie and I. But in real life, we'd probably say, yeah, Tristan's between us. But in geometry, the only way Tristan can be between us is right here on the same line, okay? So in geometry, when you see the word between, that's a collinear, okay? So this postulate just says, well, if this is the case, then when you add up these two segments, it equals the whole segment. Well, duh, okay? Another duh moment, but this is what most of these are. Now, do I have to offer proof on why that's true?
No.
No, we don't, because it's a postulate. So can we just agree that when you tape those two together, it just makes a bigger one?
Yes.
Okay, that's what this is. All right, so you've done problems like this before. Maybe not with variables. Sorry, geez. Okay, let's say that AC.
I like AC.
What does it?
It makes me hold on more days.
What did I say? AC was.
I don't know.
Let's just figure out what AC is. AC equals. Let's simplify this expression.
AC is AB plus BC.
Okay, right. So what's AB? What's the length of AB?
2x minus 7.
2x minus 7. And what's the length of BC?
3x plus 9.
3x plus 9. So if we simplify this, we're going to combine like terms, right? Remember that? Good old times. 5x. And then what's negative 7 plus positive 9? 2. So that's what AC is equal to. Okay? So they might give you, well, AC is 19. Well, if AC is 19, solve for x. They could do something like that in your homework too. So you just set AC equal to 19, or maybe 17. 17 equals blah, blah, blah. Simplify and solve that equation for x. Okay, get rid of 2, get rid of the 5, and you got your x. All right, one last little tidbit here. The midpoint is exactly what it sounds like. It's the point in the middle, right in the middle. The midpoint of a segment is the point. Now here's what's really important to see how they define this, because you can't really say the point in the middle. Because, well, what does middle mean? You can't say that. The midpoint of a segment is the point that divides the segment into two congruent segments, or two congruent parts. Okay, remember that's how you spell congruent. It divides the segment into two congruent parts. Okay, so for example, if M is the midpoint, that's how you spell midpoint, MDPT. Can you guys remember that?
No.
It's not too hard.
Yeah, it's
Of AB, then AM equals MB. Okay, so let's draw a line segment AB, and I'm gonna, as best as I can, find the midpoint and call it M. So do you see how if M is the endpoint of AB, then that means AM equals AB, right? Because it separates this into two congruent parts. So those have to be congruent. Remember that little hash mark means that they're congruent.
Black math, give me some math and I'll give you some flack. Black math.